Hello, 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 hello. Hello, dear students. Welcome back to my YouTube channel. I guess I am audible and visible to all of you. And very, very, very good evening to all of you. Am I audible and visible? Sure. So, as you can see me, I am audible and visible to you. Today, we will be discussing lecture number 4 of NLM. In the back 3 lectures, we discussed about what is the first law, second law, third law, impulse, momentum, normal reaction force, weight, apparent weight, how to find apparent weight, lift cases. We discuss all these possibilities. When two bodies are in contact, how to find the acceleration, AF net by total mass, how to find the contact force, the normal between the two objects, if the object is inclined or on horizontal surfaces. So up to this particular level, we discussed each and everything. Now from today onwards, we will be starting tension. So in this lecture, we are going to start tension. Okay. What was tension? Tension was the fourth in mechanics that we need to study. Okay, so let us start. Okay, so lecture number 4. Good evening, beta. Good evening. Okay. I hope my board is crystal clear, visible to you all. So let us start now. There is a lag now from couple of days. I hope we can manage up to this particular level. Okay. Let us start now with tension. Today topic will be tension. It is tension in string. Tension in string. Done? Sometimes due to, I guess, lot of things are going on now, right now in our area. That's why this lags happens, right? Okay. So tension is intermolecular force. Tension is intermolecular force. Tension is what? It is intermolecular force between the molecules of a string. Between the molecules of a string. And this intermolecular force, it becomes active when you are stretching. When you are stretching the string. Done? So what is tension? Tension is an intermolecular force and it gets activated once you are stretching the string. It is there present always, but it is not active. So it gets active when you are stretching the string. That means if this is my string, right? So tension is present in the string, but when you are stretching it, it gets activated. Look now, if this is my string, this is my string. If we can see to the molecular level, inside the string we are having atoms, right? Look, we are having atoms. These atoms are at equilibrium position. But when we apply force, When we apply force, what will happen? The gap between the atoms increase, and these atoms repulse or oppose. These atoms oppose change, right? Oppose the change. This opposition in the change of the atom's structure is known as what? Tension. That means here will be a force that will oppose this force, and this force is known as tension. Force tension. These are two atoms present inside the string, right? They are placed naturally at this particular distance, so that simply indicates they are at the equilibrium distance. But when we disturb the configuration, let's say we increase the distance, so our atoms tend to be at their original position, so they won't be like this now. So look, we stretch like this, but they want to go like this, right? So this particular force is an intermolecular force. This force is known as tension. This force is known as tension, and tension is always opposite to the cause of it. So if the cause is this force, so tension will be opposite to that particular cause. Clear? Now atoms are involved, so you can write it is electromagnetic, EM, electromagnetic in nature. Tension is electromagnetic in nature. Done? If you have slack means if you have loose string. If you have loose string, in loose string, no tension. If you have loose string means no force applied. If no force applied, then no tension. Okay, and tension is always positive, it can't be negative. Tension is always positive, it can't be negative, and it can be zero. So the minimum value of tension could be zero. Done, beta? Done? We are having one more type of thing, that is ideal string. Ideal string. What ideal string is? Ideal string simply means if this string is inextensible. Inextensible strings are known as ideal strings. Done? Clear? Inextensible, that means if you are applying the force and the length of that string is not changing, if you are applying the force, so that particular string is known as ideal string. Clear? And tension at every point in ideal string is same. There means no increase, no increment or increase in length. Done, beta? Suppose we have a box. This is my box, and we are pulling the box with some force F. So write the direction of tension. Look now, if you write for this particular point, force is opposite to tension will be here. Now for this particular point, right, my tension will be like this. Why? Will oppose the force, that's why it will be opposite to the tension. Okay, if we are having a rope like this, 2 points of rope, if you are applying force F here, so where will be the tension in the string? Look, if we talk about this particular point, tension will be opposite to that of the force. If we look for this particular point, tension will be opposite to that of force. So this is how we are writing tension. This is how we are writing tension. If you are done with this case, let us start now. Let us start now a numerical. Let us start now a numerical. Look now. Look now. One box of 2 kilogram. This one is of 3 kilogram. You are applying force of 50 Newton. This surface is smooth. This surface is smooth. Clear? Find acceleration and tension. Find acceleration and tension. Okay. Sir, how to find acceleration? How to find acceleration? We will make firstly the FBD. We will make FBD. So this will be my 3 kg block. My 3 kg block. This is 50 Newton force. And at this particular point, tension will be opposite. This will be my tension. So this is my tension T. If we talk about this box is of 2 kg and this will be my tension. Done? Look now, if we talk about the shortcut way, what is acceleration? Acceleration means the net force divided by mass total. What is force net? It is 50 Newton. What is mass total? That means 5 kilogram. So I guess my acceleration came out to be 10 meters per second square. Done? So my acceleration will be like this. It is 10 meter per second square. Easy? Done, no? Clear? Look now here. If we want to write tension for short, you can write tension T equals to mass into acceleration. Mass is 2 kilogram, acceleration is 10. So you can write 20 Newton. But if you are saying me, sir, show me the basics, how to do it. Now look, for this one, 50 Newton minus tension T, mass is 3, acceleration is A. For this one, I can write T minus 0, mass is 2, acceleration is A. Now add these two equations. You will get 50 equals to 5A. So acceleration came out to be 10 meters per second square. So take this equation now. T equals to 2 into 10. T came out to be 20 Newton. This is basics. Basic. This one is short trick. Now it is up to you now which formula you want to apply. Basic or you want to apply short trick. Short trick is only used for your NEET and JEE. NEET and JEE. If you are writing your this numerical in board examinations, if you want number in your board examinations, write in this way and define each and every step. Let A is acceleration, T is tension. Okay, write each and every step. Then only words you will get number, right? If you are writing shortcut now, they will go 0 to you. Tension will be same now. Look, here we take 20 now. Look, I can get answer from this one also. Look, 50 minus T equals to 3 into 10, right? Look, 50 minus T equals to 30. Done. So 50 minus 30 equals to T. So tension came out to be 20 Newton. You can use either equation. In shortcut, we can use this one. Look here, two forces are there. Now look, one force 50, one force T. But here only one force tension is there. Now that's why we are applying short trick on this one. You can apply this one also, no issue. Okay, let us do a more complicated numerical now. More complicated means this numerical is having more than two boxes. More than two boxes, right? One in this way, one in this way, one in this way. These are joined by different ropes, so you will get different tension. I am defining each and every step so that you will get a good understanding of it now. This one 5 kilogram, this one 4 kilogram, this one 2 kilogram. You are pulling it by 55 Newton. So here will be tension T1, here will be tension T1, here will be tension T2, tension T2. How many ways we are having? Two ways. Okay, that's why I will use shortcut. What is acceleration? Acceleration is force net divided by mass. Force divided by mass. What is force? That is 55 only. What is mass? It is 5 plus 4 plus 2. 5 plus 4 plus 2. I guess 55. 11. My acceleration is 5 meter per second square. My acceleration is 5 meter per second square. Now T2. So I can write T2 equals to 5A. Why? Because F equals to M into A now. So T2 is equals to 5 into 5. So T2 is equals to how many? 25 Newton. Now T1. T1. How to write T1 now? How to write T1 now? Look. We can take this box, right? I can write 55 Newton minus T1. Mass is 2, acceleration is 5. Okay, so it is 55 minus T1, 5 to the 10. So my T1 came out to be 45 Newton. T1, T2, acceleration. T1 is 45 Newton, no. How 45 Newton? Sorry, how? It is 45 now. Easy or super easy? Easy or super easy? हाँ बेटा? Easy or super easy? Okay, let's take a different numerical now. A different one. Different one will be like, look here. Look beta ji. Now my force will be somehow tilted. My force will be somehow tilted now. Okay. Everything is easy now. If you're paying attention, everything is easy. But only thing is you need to pay clear attention. Look now. My force is 30 Newton. This angle is, let's suppose 60 degree. This one is 3 kilogram. This one is 2 kilogram. This one is 10 kilogram. Here is tension T1. This is tension T1. Tension T1. tension T2, tension T2. Find acceleration, find T1, find T2. How to find all these things? Look now. First of all, I will take the component form of it. 30, so this will be 30 cos 60 degree. This will become 30 sin 60 degree. This one is not important. Why? Because it is balanced by normal reaction force and the weight of it. So this one is only important. Now look, 30 cos 60, 1 by 2, that means 15 Newton. No use of it. Now you are having a tray like thing and with pulling force of 15 Newton. I guess these two numericals are now same. Same, right? So what is acceleration? Is it force net? So my force net is 15 Newton. What is my weight? 10, 15, 15. So my acceleration came out to be 1 meter per second square. Easy. Now here T2. So I can write T2 equals to mass 10 into 1. So T2 came out to be 10 Newton. Now T1. T1 I can write 15 minus T1 equals to mass into actually into 1. It came out to be 15 minus. So T1 is 12 Newton. Easy or super easy? Prabha Haldar. Yes, beta, correct. Acceleration is 1. Yes. Easy or super easy? Easy or super easy? Gradually, we are increasing the toughness of numericals, right? It is not like that I am not giving you the tough numericals. We are increasing. First of all, we are doing basics. If basic is clear, then we are doing inclined. If inclined is clear, then we are doing some different types now. I guess this numerical is done. Now let us give you one more example. A different now. And I hope you can do it now by your own end. Look here. I want you to do it, right? You to do simple. One box, two box, 3. You will have some twist in this numerical. Look here. I want you to make also these diagrams. Pulling force. My force is F. My force is F. One is 10 kilogram. This tension is T. Here is a force of 20 Newton. This is 20 Newton. This one is 4 kilogram. This one is kilogram. Now different numerical. Clear now? Different numerical. Clear? Okay. Give me the value of tension T. Give me the value of force F. Give me the value of acceleration A. This one is bit lagging. Yes, sometimes it lags, right? But please just bear with me, right, beta? Now this numerical is different now. Why? Because I introduced here a force. How to tackle with these numericals? How to tackle with these numericals? Look now. What is acceleration? Acceleration is net force divided by total mass. So what is force? Force is acceleration A into mass. Mass is 4 plus 6. It is 20 kilogram. But we don't know what is acceleration. Take this one. Take this one. Take and create a video of it. This one is 4 kilogram. That is pulled by 20 Newton. Write equation. F equals to mass into acceleration. Force is 20 Newton. Mass is 4. Acceleration is A. I guess acceleration came out to be 5 meter per second square. Force came out to be 5 into 20. Acceleration came out to be 100 Newton. Acceleration done, force done. Now what is tension? So it is F minus T. So I can write F minus T equal mass into acceleration is how much? 5. Force is how much? 100 minus 50 equals to T. So T came out to be 50 Newton. Done, beta? Clear, beta? Prabir Haldar A is 5, F is 100. Perfect, yes? Clear? Easy? Easy or super easy? Easy or super easy? Yes, T is 50. I want you are not. Is it easy or super easy? I guess easy, no? Easy one, but a good one. Now let us have a numerical based on inclined surfaces. Based on inclined surfaces. If we are having a surface of some inclination, with some inclination, okay? So we are having two bodies now. We are having two bodies now. One body, one more body. Angle is 30 degree. This one is 6 kilogram, 4 kilogram. You are getting it with 100 Newton. Find the tension and acceleration. Give me acceleration, give me tension. Easy or tough? Yes, sure. I am giving from the look. I have not designed this lecture for only NEET aspirants. I am doing the lecture from the basics. I am giving the basics now. I am just thinking that you don't know anything about this formula, anything. I am assuming you don't know anything. So I am teaching like that now. You can see my numericals. So we got from, look now, I will show you one thing, right? Look, we got from this, how tension will be opposite to force. What is tension? I got from this particular thing to this one now, to this one now, to this one now. So I am gradually increasing your level now. I am not taking the NEET one. I am not thinking you are a 13th student. I am thinking you don't know nothing. I am teaching from basics. If you are 2026, 2027 aspirant, don't worry. Watch this lecture. You will get something, right? You can watch my 3-4 lectures. Then you will decide. Are those lectures good to your preparation? You can decide for your own. No? Okay. Now, how to tackle with these numericals? If you have this numerical, how to tackle with it? Okay, sir, I guess in previous classes, we know one thing. What we know now? Look, what we know. Look, one thing. That there will be a force, right? This force, this will be mg sine theta. This force will be mg sine theta. How? Look, I will show you how. I will show you how. Look now. Different slide. On a different slide. Look now. If this body is having mass m, this angle is theta. You can take, it is weight. Weight will be downwards mg. Weight will be downwards mg. Okay. Now why look, why we are interested in breaking down into component forms? Because we get the forces perpendicular to each other. Okay, let us suppose we are taking, look, if this is my coordinate system, if I am taking one force like that, so second will be like this, right? If one force is like this, second should be like this. So I take perpendicular forces only in physics. Okay, look now. So if this is theta, this one will be theta. and this will be mg cos theta, and here we have normal, and I just told you why there is normal, and this will be mg sin theta. If buckles is not going in this way, that means my normal is getting balanced by mg cos theta. So only one force is responsible, that is mg sin theta. That's why here will be only one force, mg sin theta. In the same way, there will be one more component of it, that means mg sin theta. It is 4g sin 30 degree. This is g sin 30 degree. Yes, that is, yes, beta. G will be same for both of them, right? Look here now. What is acceleration? Acceleration will be F net divided by total mass. Look, 100 Newton is upward, 4g sin theta is downwards, 6g sin theta is upwards. So what you need to write? You need to write, sir, my 100 is upwards, minus 4g, g is 10, sin 30 is 1 by 2, minus 6 into 10 into 1 by 2. Whole divided by total mass is 10. Look now, 100 minus 2 1s are 2, 2 5s are 10, 5 for 20. It is 20 minus 2 1s are 2, 2 5s are 10, 5 is 30. It is 30 divided by 10. It is 100 minus 50, 50 by 10 is 5. So it is 5 meter per second square. Now I got my acceleration as 5 meter per second square. I got my acceleration as 5 meter per second square. Now I need my tension now. I need my tension. I need my, take one block. Let us say I will take this one, right? So look, this one is like this. Done now. Look, 100 Newton is upwards. Here, T is downwards. And 4g sin theta, it is 4 into 10. 4 into 10, that means it is 20. 20 is downwards. So can I write now? It is 100 minus T minus 20 equals to mass into acceleration. Acceleration is 5. So it will be 80 minus T 20. T came out to be 80 minus 20. T came out to be 60 Newton. Easy or super easy? No, tension is 60, not 80. Tension is 60, not 80, beta. Done? Cross check your answer. Tension came out to be 60 Newton. And this one is very interesting topic. Easy or super easy? Yes. Perfect. Now let us do a different one. A different one now. And I hope you can do it. I hope you can do it. We are having one more inclination like this. Now, same angle is 30 degree. One object is here. It is 4 kilogram. One object is here. This one is 2 kilogram. Both are connected with a string, ideal string. Okay. Now tell me beta, what will be the acceleration? What will be the tension? What will be acceleration? What will be the tension? Okay. T again. Okay, I will show you. No, don't worry. Look now. Take this box. Okay, take this one. If you get confused, take this one. Okay, look. This is my box. Is it 6 kg? Perfectly. How many forces are acting on this box? T. T is like this. Okay. And this one is 6 g sin theta. Done. What is T? T, we don't know. Minus. It is opposite now. Look, box is going like this now. That's why I am doing T minus 6 g sin theta. That means this one is more than this one. 6 g. It is 6, 10, Sin 30 is 1 by 2 into mass. Mass is how much? 6. Acceleration is 5. 2 ones are 2, 2 5s are 10. Clear? T minus 30 equals to 30. So T came out to be 60 Newton. You can take either equation. You can take either equation and you will get your answer. If you like from one, if you like from second, you can do according to your own taste, na? According to your own comfort zone, you can do your numericals. I showed you in both the way. Now you can do it, right? Look, this is the advantage. You're seeing now. This is the advantage of your live classes. If you're watching these live classes, you can comment on me. Sir, this I don't understand this particular topic. Could you just make it more explainable for me? Could you just more explain? I can explain. Sir, how 4G is there? Why it is not going up and down? You can ask me these things, right? But if you are just seeing the lecture, no, I just recorded one. There you can't ask me anything, right? So enjoy. If you are coming into the live session for really a good purpose, not for this movie enjoyment, right? If you get bored from the scrolling things and you're just coming back so that I can see what is he's talking, right? So if you are serious about your future, if you are serious about studying, right, you can ask me your doubts. Like, I am not teaching here any regular stuff, right? You can do one thing. You can watch these lectures. Then you can comment on my lectures about my content. You can watch my lectures. Then you can do your PYQs. You can do your book. You can do your module. Then come back to me and tell me after comparing these things, right? That's what you have taught to us. Look now. So we are done with this numerical. Now let us do. Okay, this one. Okay, give me the answer for this one. I am waiting for your answer, beta. Ria, I am waiting for your answer. Parabir, I am also waiting for your answer, right? Only two students are active. So I am asking only you two. Give me the answer for this one. There is no external force being applied on it. No external force. That means we are not applying anything from our end. Give me answer, right? Give me the answer. And you will get noted one thing, that when there is a force, there will be a tension. If there is no force, there will be no tension. Acceleration is 5 meter per second square. So you got acceleration as 5. That is great. Which one? Which one? Is this acceleration for 4 or for 2? Is this acceleration for 4 or for 2? Or for both? Done? Take your time now. Take your time. Think about it. How we need to do these things. How many forces are being applied on it. How to do it. I guess you are done. Look now. Look now. Look now. One force will be there. Mg sine theta. Same way. Force will be there. Mg sine theta. Done? Easy? Okay. So what is acceleration? Net force. What is force? Mg sine theta. What is mass? Is it m? Cancel out g sine theta. So this is going downwards with j sine theta. This one is going down with g sine theta. That means acceleration is same for both of them. Acceleration is same. If the acceleration of same for both of them and they are going downwards, so tension will be 0. Tension is 0. Why? Because there is no effect of these accelerations on particular rope. If no effect of the acceleration on this rope, so no, there will be no tension. There will be no tension. Yes or no? Now, I will be giving you one numerical for your homework. I am giving you one numerical for your homework. And the numerical will be like a difficult one. This will be a difficult one now. So we are having a block. We are having a block 6 kilogram. One more block. One more block. Mass is 2 kilogram. Mass is 4 kilogram. Here tension is T2. Here tension is T1. Applying force 120 Newton. This angle is 30 degree. Find T. If you want to find acceleration, find A also. This one is your homework. Find tension T1, that means T1, and T2, and acceleration. Done? Easy or super easy? Easy or super easy? Easy? What is A? A is simple, na? G. What is G? G is 10. Sin theta is 1 by 2. That means 5 meter per second. You are correct. 5 for both of them. Easy. Is this one easy now? Then? Okay, look now. What will be tension? What will be tension in uniform rope rod? That means if we are having now a rope or a rod, this is my rope or a rod, like this. Okay, mass of this rod is M and length of this rod is L. Length of this rod is L. Mass is M, length is L, and this surface is frictionless. This surface is frictionless. Done. You are applying force here. Force F. You are applying force here. So what will be tension here? It will be T1. Suppose here it is T2. Here it will be T3. So how to find these tensions? Look, if my rope was ideal, so tension was same. So, but this is not ideal case one. It is a uniform rope. It has some width, right? It is not a thin one. So every point the tension will be different. So how to find the tension of at different points? How to find? Clear now? Look, to tackle with this thing now, first of all, what is acceleration? Acceleration is net force by mass. So this is general formula and a universal truth formula. So this is my acceleration and you know it. Force is M, force is F, mass is M. So we got our acceleration. Now, how to find now tension? To get my tension, what I can do now? Look, I will, let us suppose I need to find out tension this one, this T1. So what I can do? Look, if this is my uniform rod, right? If this is my uniform rod, what I can do? If length is L, mass is M, so here I need to find out tension. So I will just cut it down here. I will cut it. And the distance from this particular end to this one will be X. So this one will be L minus X. Okay. If mass will be here m1, mass will be m2, and force is same as it is F. Done now? Now join back these two things now. Join back. How to join it now? Take this one. Take this one. Now join these two by a string. Suppose these are joined by a string. Okay. Now what will be the value of this tension? That we need to calculate. Mass of this one is m1. It is x. Mass is m2. It is L minus x. Okay. And force is applying F. Now we break down this problem. We break down this problem into the smaller one. What will be tension? What will be tension? So I can take this one now. Tension. Look, it is T. T minus here is no force, T minus 0 equals to M into A. So M is M into 2 into A. So tension came out to be M2A. Tension. It is M2. Acceleration is F by M. It is F by M. Done. Now we have to calculate M2. Look now. Look now. We are having a rod. Rod length is L. Mass will be M. So L length rod is having mass M. So one unit will be having M by L. 1 unit of length is having mass M by L. Clear? So look now. So x1, that is mass 1. So mass 1 equals to M by L into x. Mass 2, it will be M by L into L minus x. So I can write T is equals to M by L, L minus x, F by M. M cancel out. It came out to be F by L, L minus x. This is my answer. Clear? Or you can write F 1 minus x by L. This is the final answer that you need to remember. You need to remember this one, how I got this one. This is known as unitary method. Unitary method. Easy or super easy? Easy or super easy? Hamida? Easy or super easy? Okay, if this one is easy, so I will give you a numerical. Numerically, like we are having a rope. It is length is 9 meter. Then it is mass is M. You are pulling it with the force of 18 Newton. Here, this particular point is 3 meter away. Here find tension. Find tension T. How you can do it now? How you can do it now? How you can do it now? I guess my acceleration is nothing but F by M. Done. And my tension is nothing but it is F by L, L minus x. Use the formula and give me the answer. Use the formula and give me the answer. Okay, look now. First of all, what is acceleration? F is 18, mass is m. It is m, no? So my acceleration came out to be 18 by m. First, what is my tension? What will be my tension? It is F by L, L minus X. F is how much? 18. Length is how much? 9. L is how much? L minus X. It is 9 minus 3. 9 minus 3, that means 6. Done? I can write here, look, 3 3s are 9, 3 2s are 6. 3 1 is 3, 3 6s are, 6 2s are 12. So 12 Newton is my tension. Easy or super easy? Easy or super easy? हाँ बेटा, easy or super easy? Easy, right? Okay, super easy. S is super easy. Okay. Now write the next topic as bodies hanging vertically. Bodies hanging vertically. Bodies hanging vertically. Okay. How, sir? Look. One block. One more block. One more block. With mass is m1, m2, m3. So there will be tension T1 here. Tension T1. Tension T2. Tension T2. Tension T3. Tension T3. So how to find these tensions? How to find these tensions? Clear? There won't be any acceleration now. Why? Because they are connected with one another, so acceleration is 0. There won't be any acceleration. Won't be any acceleration. So first of all, I will write it is what? FBD. So I will make it FBD. Take this one, this one. So this is like this, M1. There will be a T1 tension. Weight will be downward, that means M1G. So simple indicators T1 is equals to M1G. Take this one. I will make it here. It is M2. Upper is tension T2. Lower is tension T1. And lower is mass M2G. I can write T2 is equals to T1 plus M2G. M1G. T2 is 2G. Came out 1 into G. Now this one T3. So I can write here T3. Now T3 like this. It is M3. There will be T3. There is T2 and M3G. I can write T3 is equals to T2 plus M3G. A T2 is M1 plus M2 multiplied with G plus M3G. So I can write it is M1 plus M2 plus M3 into G. It is my T3. This is how we can find T1, T2, T3. Note down the whole thing, then I will show you the shortcut trick for it also. A shortcut trick. Every time don't know, no, you don't need to make all these FBD diagrams. I will show you shortcut trick now. I will show you the shortcut tree. The shortcut one. Okay, now done. Look beta. Shortcut. Shortcut. Shortcut, but the system should be at rest. System at rest. System at rest. So I will show you the shortcut trick. Now look. One, two, three. M1, M2, M3. T1, T2, T3. Done. So tension will be equals to mass below into G. Mass below into G. Suppose you need to write T3. I will write T3. How many masses are hanging? Sir, 1 mass, 2 mass, 3 mass. So add all these masses. It is M1 plus M2 plus M3 into G. So you can see T3 is same, no? I can write T2. T2. Mass below. Mass is M1 plus M2 into G. T1. Mass below. It is M1 into G only. This is how we can do it. Easy or super easy? Easy or super easy? Okay. Now, this particular thing was at rest. Now, if the system is moving upwards, if the system is moving upwards or downwards, if the system is moving upwards or downwards with constant acceleration, with constant velocity. If there is constant velocity, that means my acceleration is 0. My acceleration is 0. So formula is same. T mass below into G. This one. So this is used for if upward or downward with constant velocity. Second case, if you are getting upward now, upward with acceleration A. Now T is equals to mass below into G effective. I can write T equals to mass below. G effective will be G plus A. Why? Take lift case. You know the lift case now? Lift case. Same as lift case we need to discuss here. The apparent weight type, right? Third one. Downwards. Downward with acceleration. With acceleration A. So T will be mass below G effective. So you can write mass below G minus A. Why? Because G is more than A. Done? Easy or super easy? You need just do like the same that you are doing is what? In lift case. I guess this is very easy now. You can do it now. So we will be doing a numerical based on this property. I need a break of 2 minutes. Okay, I need a break of or 3 minutes break. 3 minutes break. Hello, beta. We are having 40 seconds, right? Okay, so let's start. Break time and hello, beta. Look now, let us start a numerical. We are having a case. Okay, okay, okay. So we are having a box. One box, two boxes, three boxes. 6 kg, 2 kg, 2 kg. Tension T1, tension T2, tension T3. Find T1, find T2, find T3. First case, lift is going upwards with acceleration 5 meters per second square. Second one, downwards with acceleration 5 meter per second square. Done. First case. What is T3? T3 will be mass below, that means M1 plus M2 plus M3 into G plus A. I will take parallel case of it. It is 6 plus 2 plus 2, it is 10. G plus A, it will be 15. My answer came out to be how much? 150? Yes, 150 Newton. First case. B case T2. T2 will be 2 plus 2 and G plus A. This will be 4 kilo and 15. It will be 60 Newton. C case T3. T3 is 6. No, it is 2, right? No, we are having, sorry, T1. We are having a T1. T1 is 2 multiplied by 15, that is 30 Newton. Here, I will take T3. This will be M1 plus M2 plus M3. Then here it is G minus A. This will be 6 plus 2 plus 2. G minus 8 will be 5. So it will be 10 into 5. That came out to be 15 Newton. Then we are having T2. T2 is equals to 2 plus 2, 4. 4 into 5. 5 for 20 Newton. T1 is equals to 2 into 5. 5 to the 10. It is 10 Newton. Easy or very easy? Easy or very easy? Done? Okay. One numerical. Now, let us start pulley cases now. Now, let us do a pulley system. Pulley systems. Do you know what is pulley systems? Do you have any idea about pulley systems, beta? First point, ideal pulley. Ideal pulley is massless. Ideal pulley is massless and frictionless. Ideal pulley is massless and frictionless. Clear? Just like ideal string. Ideal string is massless. Ideal string is massless and inextensible. Clear? So what is the function of pulley? Change the direction of force. Change the direction of force. Change the direction of force. Okay. Change the direction of force. It is the only and only function of pulley. How, sir? Let us suppose we are having a pulley. Look now. Let us suppose we are having a pulley case. Look, this is my pulley. You are applying force here. Right? Here. So this pulley gets up. So it is reversing it. It is reversing it. And short trick is also present. Acceleration is net force divided by mass. Acceleration is net force divided by mass. This one is already present. And you know it very well. Everything great, everything done. Do a numerical now. Let us do a numerical now. We are having a pulley system. We are having a pulley system. We are having a pulley system. Two blocks are associated with this pulley. Two blocks are connected with this pulley. This one with mass m1, this one with mass m2. Okay, now you can see from this particular figure, if let us suppose I will take you that if mass m1 is more than m2, if I will write here m1 is more than m2, so what will happen? This block will go down, this block will go up. Due to weight will be m1g. The weight of this one will be m2g. Tension will be upwards. Tension will be upwards. Done now? Look, so acceleration of going downwards will be A. Acceleration of upwards will be A. Now make its equations now. Equation for m1. So can I write here that m1g minus t equals to m1 times A? Can I write now m1g minus t equals to m1A? It is first equation. Now for this one now, which one is more? T is more, now it is going up. So can I write now t minus m2g equals to m2A? Second equation. Add both the equations, what you will get? You will get m1g minus t plus minus m2g equals to m1a plus m2a. T cancel out, so I will get here m1 minus m2 multiplied with g. Here will be m1 plus m2 into a. So my acceleration came out to be m1 minus m2 into g divided by m1 plus m2. Easy or super easy? Easy or super easy? So but short trick is there now. What is A? Net force divided by net mass. What is net force? One force is m1g. So I can write more force. More force is m1g minus m2g. Total mass is m1 plus m2. You can write it now. m1 minus m2 into g divided by m1 plus m2. This one is by short trick. This one is by short trick. This one is from basics. Clear? So we got to know that how to find acceleration. Now what about tension? How to find tension now? Let's suppose I will take one equation. Tension T minus m2g equals to m2a. So tension came out to be m2g plus m2a. I can write like this now. Look now, tension equals to m2g plus m2. What is A? A is equals to m1 minus m2 divided by m1 plus m2 into g. Can I write like this? Look, can I take mt equals to? I will take m2g common. It is m2g. There I have here 1 plus m1 minus m2 divided by m1 plus m2. Look, t equals to m2g. Then it is m1 plus m2 plus m1 minus m2 divided by m1 plus m2. Look, M2 and M2 cancel out. Done. So can I write from this particular thing now? T came out to be, look, M1, M1, 2 M1. It is 2 M1 M2 into G divided by M1 plus M2. This is my tension. Easy or super easy? Easy or super easy? Huh? If somebody will ask you, find reaction force. Find reaction force. First of all, you need to understand what is reaction force. Look, at this particular point, look beta. Tension T is here. Tension T is here. It is get balanced by this tension. So this is reaction force. It will be 2T. T plus T, 2T. So this 2T is the reaction force. This 2T is the reaction force. Clear? So on this particular slide, we come to know that how to find acceleration, how to find tension, and how to find a reaction force. How to find a reaction force. Done? Easy enough? Okay. Let us do one more numerical. Numerical will be like pulley. There will be two boxes. Two kg. 3 kg. Find an acceleration. Look, 3g, 30 Newton will be downwards. 20 Newton downwards. Tension up, acceleration down, acceleration up. This will be 2t. We know this thing very well. Yes, sir. What will be acceleration? Net force by m. Net force by m. What is net force? It is 30 minus 20 divided by 5. It is 10 by 5. It is 2 meter per second square. So my acceleration came out to be 2 meter per second square. For tension, make FBD. Make FBD of this one. I can write 30 minus t equals to mass equals to acceleration. It is 30 minus t equals to 6. Tension came out to be 30 minus 6. Tension is 24 Newton. Easy or super easy? Easy or super easy? Easy? Okay. Look now for second numerical. Look here. If we have a numerical like this, okay. Two kg. 1 kg. 2 kg. Clear? Here is tension T. Tension T. Here is tension T dash. Find acceleration. Tension T. Tension T dash. These three things we need to find out. T tension, T dash tension. Clear? Yes, sir. Look here. First of all, I will mark the forces. Weight will be 20 g, 20 Newton. This will be 20 Newton. And here is 10 Newton. Clear? So acceleration, it is 30 Newton minus 20 Newton divided by 2, 5. So it is equals to 10 by 5. It is 2 meters per second square. So acceleration came out to be 2 meter per second square. Done? Easy? Look, so this acceleration is downwards and this will be upwards. Take this one now. Look, so I can write 20 minus t dash, mass is 2, acceleration is 2. 2 to the 4, so t dash came out to be 20 minus 4, it is 16. T dash came out to be 16 Newton. 16 Newton. Now for t, I can take this one. It will be t minus 20 equals to mass equals to acceleration. Clear now? So t equals to 4 plus 20 came out to be 24 Newton. 24 Newton. Easy or super easy? Very easy, no? So by this thing we conclude how to find numericals. Okay? Now let's take few problems. Few more problems. Let us take few more problems. Look now. Here we are having a pulley. Object. One more object. 3 kilogram. 4 kilogram. Tension T. Tension T. Tension T. Tension T. Clear? Find acceleration. Find tension. Find a reaction force. Okay, look now. 30 Newton is downwards. 40 Newton downwards balanced by its normal reaction force. Clear now? Acceleration is net fed by mass. What is force? Only 30 Newton is there. Force will be 4 is 7. It is 30 by 7 meter per second square is my acceleration. Now tension, I can write for this one ABD. T minus 0 equals to mass is 3, acceleration is 30 by 7. T came out to be 120 by 7 Newton. Super easy. Now reaction force. This will be my reaction force. Reaction force, right? Reaction force. Now look. Tension T. Tension T. This is my force. To tackle this force, I have one more force, it is R. To reaction of this force. Okay. Two forces are acting on 90 degree. It will be 2F cos theta by 2. 2F cos theta by 2. Okay. 2. F is T. Cos 30 by 2 is cos 45. Cos 45. It is root 2. I have root 2 times T. Root 2. What is T? T is 120 divided by 7 Newton. This is my reaction force. This one is my reaction force. So I can write here a reaction force. A reaction force. Easy or super easy? Easy or super easy? Easy, no? Okay, let us do one more numerical. One more numerical. Shall we continue the class or we will take the numerical tomorrow? Shall we continue the class or take tomorrow numericals? Because it is almost 90 minutes, right? Now, take this class, continue class or take the class tomorrow down? Shall I continue the class or take the restings tomorrow? No, I am, I don't have any issue, right? I can take the class to 10, 11, 12, no issue for me. You should have the time to revise it also, right? I don't have any issue with it. I can extend by 1 day, no issue with it. But you should get a time to revise it, no? Okay, great. Look now, if we are having a thing like this, look now. A good numerical. Okay. There is a pulley. Mass is 8 kilogram. Is 2 kilogram. This angle is 30 degree. Okay. What will be acceleration? What will be tension? What is acceleration? What is tension? How to find it? Look now. ABD. 20 Newton downwards. There will be normal, no issue. This one will be mg sine theta. Mg sine theta only. Done now. M is 8, G is 10, sine 30 is 1 by 2. 2 1 is 2, 2 5 10, 8 5 are 40, it is 40 Newton. Okay, what is acceleration? Net force. Net force divided by total mass. Net force. Is it 40 only? 40. Divided by mass is 10. Acceleration is 4 meter per second square only. Okay, take this FBD. It is t minus 0 equals to mass. Mass is 2, acceleration is 4. T came out to be 8 Newton only. T came out to be 8 Newton only. Done. Done now. Okay. One more numerical, a complicated now. We are having a numerical as little bit of complicated. Look now, beta. Look now. Little bit of complicated. 1 kg, 2 kg, 53 degree. Okay, so look, tension will be T here, same T here, because we are having same rope, so tension will be same throughout. Tension will be same throughout. Now take FBD. Take FBD. 10 Newton balanced by normal reaction force. Here mg sine theta. M is 2, G is 10, sine 53 is 4 by 5. 5 1 is 5, 5 2 is 10, 4 4 16, 16 Newton. What is acceleration now? Is it 16 divided by 3? Meter per second square. 16 by 3 meter per second square. Find tension. I will take FBD of this body. It is T minus 0 equals to mass. Mass is 1, acceleration is 16 by 3. So my tension came out to be 16 by 3 Newton. Super easy. Super easy. Super easy, no? Super easy. Okay, we're having a subtopic of this one, that means movable pulley. That is movable pulley motion. Movable pulley motion. Movable pulley motion. That means now my pulleys are now also available to move. We will be having something like this. Look. Movable pulley case. M1, M2. So M2 is more than M1. M2 is more than M1. Look beta. Tension is here 10. This tension will be T. This will be T. T. Okay. So here will be T. This will be T. T, 2T. This will be 2T and 2T. Done now? If the acceleration of this one is A, acceleration of this will be A by 2. Do you know why? Do you know why? Huh? Look, we are having a thing. Look now. So we can do one thing now. Look, I can take mass of 1, or look, I can take one thing. That is constant motion now. Constant motion equation. I can take that thing also. How? Tension into acceleration. Tension equals to acceleration. So can I take now? TT cancel out. So A2 is equals to A by 2. That's why my A2 is acceleration, which came out to be A by 2. Yes, 2 pulleys. 1 pulley is there now. 1 pulley and 1 pulley. But it is movable now. It is movable. Now we are having tension. We are having acceleration. We can do it now. How? Look now. Look now. Look beta. Look beta. I will make it FBD. M1 mass, weight is M1G, and my acceleration is like this, and tension like this, right? I can write T minus M1G equals to M1A. First equation. For second box, with mass M2, weight will be M2G, acceleration will be A2, that means A by 2, and tension is 2T. I can write here M2G minus 2T equals to M2A. A is G, A by 2. A by 2. Second equation. Now we are having these two equations. We can manipulate the equation and we will get the answer. Okay, how we got a by 2? How we got a by 2? Look now, look now, look now. Look beta. Look here. Take this one and this one. Clear? Do one thing. Multiply tension with area. Here tension with acceleration, tension with acceleration. If here acceleration is A1, here acceleration is A2. What you will write? You will write tension into A1 equals to tension, that is T2 into A2. This is my main cause, main thing that you need to write. Tension A1, tension A2. Okay? Tension A1, tension A2. Or you can do one thing. Summation of tension to acceleration equals to 0 of a system. Of a system. You will get its proof in work power energy. Okay? Let us do one more numerical. One more numerical based on the only that thing, right? Look now. M1, M2. There will be T, T, so 2T. If 2T, so acceleration क्या होगा? A by 2. So my acceleration would be A by 2. Done. So M1G downwards, up will be N. Tension is T here. Same tension will be T here. Same tension is T here. I will write equation. What, sir? T1 A1 equals to T2 A2. We know it now. T is T, A is A, equal T2 is 2T, A2 is how much? A2. So can I write now? A2 came out to be A by 2. That's why I wrote here A by 2. Make the equations. Look, M2G. I will write here M2G minus 2T equals to M2A. M2A, A is A by 2. For this one, I can write T minus 0 equals to M1A. So my tension came out to be M1A. I got my tension. Done. So we are done with pulleys. Now tomorrow we will start with string constraint motion. String constraint motion. Tomorrow we will start string constraint motion and spring force. Tomorrow, okay, we will do string and we will do what? Spring motion. And if time permits, we will do frame of reference, non-inertial. For tomorrow, I hope you will revise these things. What, sir? You will revise constraint motion, you will revise spring force, you will revise non-inertial frame of reference. Today we discussed more than enough. Okay, I will save first of all the PDF. It is NLM 4. Now we are left with how many topics? Spring cornerstone motion, spring force, non-inertial frame, then friction, friction, friction. Only these much topics are left now. Okay, so I will try to complete it within 2 or 3 days. Then we will start circular motion. Done? Any issue? Do you have any issue with this topic or today's class? Thank you, beta. I guess we done today's class of how many minutes? 100 minutes now. So I hope you enjoyed today's session. If you want to ask me anything, you're most welcome. Comment session, you can just ask me these things, right? And if not, then you can just mail me. You have my mail ID associated with this description part of channel, or you can ping me a message in Telegram also. Okay. Thank you very much for today. Thank you, beta. Thank you. Good night. Bye. Bye. Take care. Bye, beta.